Hi, this is Bob from INSYDIUM, and in this video we're going to start to build our rig to create this amazing particle snow peel effect. So we'll begin by creating some custom geometry using particles. We will then learn how to animate that geometry so it peels away, and then of course we'll add the all-important particle simulation. So let's jump into Cinema 4D and get started. So here we are in Cinema 4D, and here is our lollipop geometry. So let's have a look at what we need to do to start simulating this scene. So this actually obviously is mostly a particle simulation. Let's just have a look at our beauty. Here's our picture viewer. So it's mostly a particle simulation. These big lumps of snow are particles. These tiny little lumps of snow are particles. These nice illuminated balls are particles. It's mainly a particle simulation. But underlying that, which is really important, is that we have some geometry animation as well, and that geometry is the snow shell that's peeling away. So if we come to this frame, you can see the edge of our snow shell here. This is the covering of snow, and this is peeling away, and whilst our particles peel off. So it's the combination of that geometry animation and the particle animation that sell the shot. And we need to begin by making this geometry snow shell. So let's just move that away. So the way in which we're going to do that is we're going to actually mesh some particles. Now first, we need to make the geometry that we're going to emit those particles from. So to do that, what we need to do is basically encompass this lollipop, and we're going to do that with a primitive cylinder. So let's just go to our primitives menu here. Let's bring in a cylinder. Let's hit ND so we can see the lines. Now we want this to be orientated not up and down. We want it to be going off in the Z. So let's hit -Z for the orientation. That's it, and then we can move that up and just eyeball this for now. And we need to make it bigger so it's pretty much encompassing our candy a bit more. Just about swallowing it up, okay, and then we can make this thinner until we see it poking through, so something like that. We've got a little bit of coming out the bottom here, so I don't think we've quite got it perfectly aligned. Now we could precisely align this and get the radius spot on by going into our sweeps and having a look at the details of our helix splines which are creating this geometry. But actually, look, this is snow. It doesn't matter if it's a bit irregular looking. That's what we want. So look, let's just bring that down a little bit and a little bit more. Okay, it's just poking through on those top bits, but that's going to be fine. Now we need this to be a little bit more circular. At the moment, it's a bit jaggedy because it doesn't have enough segments. So let's go to our cylinder, rotational segments, and put this up to 50. Now we've got a smoother circle, and now look, that's completely encased our lollipop. Right, so this is going to be used to emit some particles, and then we're going to mesh those particles to make our nice bumpy snow shell. So let's go to our INSYDIUM menu, X particles, and bring in an XP system. This is our organizational hierarchy. By default, we have an XP emitter. If we hit play, you can see that, look, we've got this rectangular emitter spitting out particles, but we want to emit from our cylinder. So let's go to our emitter. We can actually go to the emission tab before we look at the object, and we want to change the emission from rate to shot, so it's just coming out on one frame. So there we've got one set of particles, and we want no speed. So let's just come down and remove this basic particle data default speed of 150. Let's put that on 0. And in our shot count, at the moment we're shooting out 1,000 particles. Let's put this really high. Let's put something like 90,000. And now we have 90,000 static particles. But we want them on our cylinder, not on this emitter rectangle. So let's go to our emitter object tab and change the default emitter shape from rectangle to object. We want to emit on an object. It's saying which object you want to emit on. So let's drag in our cylinder into this link field. And if we hit play now, you'll see that we're just getting, it doesn't look like we've got 90,000 particles, does it? We've got one particle in the center of every polygon, but actually there's just lots of particles on top of each other in this position. And the reason they're in the center of the polygon is because if we have a look here, we have, look, emit from polygon center. And we want this not to be the center, we want to cover the surface of this. So let's change it from polygon center to polygon area. We'll resim, and now we've got particles all over this cylinder. But actually, we're not ready to mesh this as a snow shell yet, because at the moment, if we just have a look at our picture viewer again, you'll see that our camera position and angle doesn't change from here. We only ever see this front side, this front face of our candy. We don't see what's behind it. So, with that in mind, there's no point in creating an animated shell from behind the candy that we're never going to see, and that means that we're never going to create particles that we're never going to see in the render, which means it's a more computationally efficient scene if we only create the geometry and particles in the bits that we're going to see. It has other advantages as well, which we'll explore a little bit later. So basically, we just want to emit from the front of the cylinder. How do we do it? Well, in our emitter object tab, by default, we're in the emitter settings, and this is where we've changed the emitter shape and the emit from area. But look, we can also go and use a fall off. So if we click on this fall off and we change the shape from infinite to box, now if we just leave that where it is and resim, you'll see that it's emitting on the surface of our cylinder, but only within this box. So what we can do is, look, let's move it so it's all the way in, and then we just want to pull this out so we're not going to be getting particles down this bit. Okay, so maybe something like that. There we go. So it would be nice if we had a bit of a smoothened edge here rather than this 90-degree angle. So we can do that. If we go to our cylinder, we can go to the caps and we can add a fillet. And let's make the radius a bit bigger to make that a bigger curve, and maybe add 2 more segments. So now we have curved this edge of our cylinder, and now we have particles which are following that shape. So now if we make our cylinder invisible, we can see that, look, that shell of particles that we have made, which is covering the front of our lollipop. Perfect. So now we've got that, we want to turn these particles into a mesh. We want to mesh them. So to do that, we need to go to our generators menu, because we need to generate a mesh. Let's go to the generators. We'll choose an open VDB mesher. And this can mesh geometry, it can mesh splines, and it can also mesh particles. So in the open VDB mesher, all we need to do is drag our emitter into this box here. And there we've got this really big bulbous mesh. It's way too big. So why is it so big? Well, the reason is what it's doing, it's meshing a sphere around every particle. And the size of that sphere is based on the particle radius. And if we just come down here, you can see that we have under the point options a point radius of 10. Now, this is a multiplier of the particle radius. It's timesing the particle radius by 10. And the particle radius, if we have a look in the emitter, emission tab, is set to the default 3. So it's making a 3 times 10, a 30 centimeter radius around each particle. And we can actually see that happening if we go to our emitter and just put this to a shot of one particle. Let's just emit one particle. There it is. And because we're meshing the particle with a point radius of 10, we have a 30 centimeter radius mesh. And we can just verify that if we bring in a sphere primitive and set this radius to 30 and then move that up. There we go. So confirmed. That's what's happening. Let's get rid of that sphere. So now if we go back to our emitter and emit all of those particles, back to, what was it? We were on 90,000. There we go. Resim. It's meshing those, but the radius is just too much. So let's go to our mesher. Let's go back down to that point radius setting and reduce this down to say 3. That's better. Now if we reduce this point radius down too much, we won't have enough polygon resolution to actually create this mesh. So look, let's put this down to 2. That's fine. If we put it down to 1, now we don't have enough, look, it's disappeared, we don't have enough polygon resolution. And what dictates the polygon resolution is this voxel size. So let's just put that radius back to 2, so we've got a mesh. And if we reduce this voxel size to say 2, look at the mesh and you'll see that we have much smaller polygons and we have more of them. So now we have a lower voxel size, we're able to bring this point radius value down even lower. And there we go. So there we have our thin shell of particles. So that's looking pretty cool. I think we could perhaps risk having that slightly bigger. Let's put it on a 1.5. A little bit more bulbous, because we want a bit of depth to it, because it's going to crack off and look like our cool cracking snow geometry. So that is looking good for our snow shell. So we don't really need to keep editing this. Now you could keep a copy of this system just in case you wanted to go back to make your snow shell. So let's just do that out of safety. We'll go to our XP system and let's go to the basic tab and we will call it system snow shell. Okay, and we're going to keep this here, but what we will do is let's just make a copy of this OpenVDB mesher. So let's highlight it, hold Control, and I'm going to drag this outside of that system. Here's our mesher. Let's hit C to make that editable. It'll make it a polygon object. So we'll hit C, and let's just call this snow shell. All right. And then with this system, let's just minimize it all. We could put our cylinder that we used in as part of the emitter to create those particles. Let's put that in our utilities folder. Close this down. And then we will hold Control Alt and click disable. And hold Control and Alt and make it hide it from the viewport and from the renderer. And the reason that we held Control Alt where we clicked on this cross and these is that if we open it up, it applies it to every single one within that hierarchy. So now this system is deactivated, it's not doing anything, but should we need to go back to it to make a new shell or to adjust it, we can. But now we have 2 bits of geometry in our scene. We have our lollipop and we have our newly created snow shell. Now before we start animating particles in this scene, we actually need to animate this geometry, this snow shell. We need to kind of cut into it and have it kind of almost disintegrate away, which will then go along with our particle simulation. And the way we're going to do that is with quite an old technique really, using a Boole object. So what we're going to do is we're going to use a scene primitive sphere. Let's bring that in. Here's a sphere. Let's move it up here. And we're going to animate this, and as it intersects with our snow shell, it's going to cut away from it. So the way we get that to work is this. We go to our menu here and we bring in a Boole object. There it is. Now by default, the Boole object is actually it's set to high quality, which is going to create a high quality mesh, but it takes longer to simulate, to calculate. We don't actually need that at this draft stage. So let's just switch off high quality. And by default, the Boolean type is set to A subtract B. And this is what we want. We want an A object, which is going to be our snow shell, and we want to subtract the B object from it as it intersects. And the way we set up which object is the A and the B object is just the order in which they are in the hierarchy of the Boole. So let's put the snow shell in first. That's going to be our A object. And then let's get this scene sphere and make that a child below the snow shell. So now the sphere is the B object. It's disappeared. It's still in the scene. And as we move the sphere, it takes a chunk out of our snow shell. And this part of the new kind of Boole object is taken from the surface of the sphere And this part is obviously the original surface of our snow shell. So we want to make a couple of adjustments to our sphere first. So let's just switch off the Boole so we can see it again. At the moment, in the standard type in our object tab of the sphere, we get these kind of pinched polygons at the poles, and we actually want square polygons as even as possible all over this sphere. So the type we're going to use to get that is not standard, it's going to be hexahedron. So we get these square polys, and then we want loads more polygons. So to get that we need more segments. Let's try this on 96 instead of 16. Yep, that's looking better. So now if we switch our Boole back on, you'll see that we've got slightly neater polygons here, but because our Boole, remember, is in the quick non-quality mode, we're getting quite a lot of triangles, and this isn't the tidiest mesh in the world, but we get really good quick calculation and playback as a result. So let's just make a few more adjustments. We're going to animate this sphere on to take the first chunk out of our lollipop. It doesn't need to be quite this big, so let's go to the sphere settings and bring that radius down from 100 to, let's try 70. That's looking a bit better. Now obviously if we just animate this sphere on like this, it does get rid of our geometry and cuts out this chunk, but it's very regular and we want to roughen this up a bit. So the way we're going to do that is by deforming the surface of our sphere. So let's again just switch the Boole off so we can see what's happening. We're going to use a Cinema 4D deformer to do that. So let's go to our deformers menu here, and we're going to bring in a displacer deformer. Let's drag that as a child of our sphere. Now what this is going to do is it will displace the vertices, the points of our sphere polygons, but at the moment there's nothing driving that displacement, so there isn't any. What we need to do is go to the shading tab of our displacer and put a shader in here, and we're going to use a noise shader. So let's pull this down, we'll bring in a noise, and as soon as I bring in this noise, look at the sphere, and now its surface is being displaced. Those vertices are being pushed either inwards or outwards dependent on the black and white values of this noise. And if we just leave it as default and switch back on the Boole, you'll see now, look, we're getting a nice jaggedy edge of our sphere. So that's looking much more organic. So let's make a couple more adjustments. Let's go to the noise and let's just increase the scale up to, let's try 150. And we could go to the displacer object tab. Now at the moment those vertices are being pushed either 10 centimeters plus or negative dependent on the noise black and white values. So we could increase this so there's a bit more displacement, maybe 16, a bit more jaggedy. Okay, and then let's just try leaving that as is. So now what we want to do is animate our sphere to give us some nice animation. But if we animate it this way, you can see that because our edge of our sphere deformation is static, it doesn't really look right. We need this to be kind of moving. So instead of animating it on the x-axis, if we animate this on the z-axis, look what happens. That looks much better. And now we're getting that really nice organic edge. So we could do with a little bit of x-axis animation, but mostly in the z. So let's go to frame 0, go to our sphere, pull this out, and we want it to be just keyframed before it started. Let's go to the coordinates of our sphere and add a keyframe on the x, y, and the z. Then let's go forward to, actually we haven't probably got enough frames here, let's increase our timeline to 180 frames. Then on say frame 150, let's animate that z value down to somewhere like that. Look, maybe be a bit closer than that, something like this, look. Okay, and then add those keyframes. So now we've keyframed in some animation of that sphere, and that's giving us this nice effect as it's almost kind of melting away or crumbling away at our snow. Now we need to make some more adjustments here. So let's go to the frame 150, where we have our final keyframe, and we want this X to be over a bit. We want more of it revealed, so something like that. Let's hit that X animation. And then at the beginning, we want it to start a little bit further over this way. So let's go to the frame 0, move this over a bit and add an X. So now we've got kind of we've got diagonal movement of this sphere. Let's switch off the Boole so we can see that. It starts here, it moves inwards, starts intersecting that lollipop shell, and when we switch the Boole on, that is what's cutting out that snow shell. And if we hit play, that's looking pretty cool. Now obviously we can just leave it at that, but we can make adjustments to this when we need to. But that is the basic principle of how we're going to animate this geometry down. Now we can add some more spheres to this to maybe simultaneously cut out a chunk here and another one. Let's cut out a chunk down here. So how are we going to achieve that? Because if you remember, our Boole is working on the principle of an A object and a B object. We actually want lots of B objects. So how are we going to get that sorted? Well, we're going to use an object which is going to join together our 3 spheres when we have them. So the way in which we'll do that is, look, let's just take our B object, the sphere, out of the Boole. And instead of that, we're going to use an XP join, which is an object which joins multiple objects together. So let's go to our INSYDIUM menu, X Particles, Utilities, and we'll bring in an XP join. The join we're going to make as our Boole B object, and actually let's rename it. Let's call it join spheres. And then look, if I put my sphere as a child of the XP join, now our Boole object is working just as it did before. But I can now duplicate this sphere and have multiple spheres in the same join, which is the B object, which means we're going to be able to cut out further chunks. All right, so that's looking good. Let's take this sphere then. I'm going to hold Control and let's drag a copy. So now we have 2 sphere 1s. This one, we want to go to the Coordinates tab and we want to delete all of these keyframes that we'd put in. And a quick way of doing that, look, we can just hit the P here, so it all goes yellow, the position for the X, Y and the Z. And if I right click, I can go to the animation menu and we can hit delete track, which will delete all of those keyframes. Then I can take sphere 1, move it over here. Now this one, let's have a smaller sphere for sphere 1 so that it's just cutting out a smaller chunk. So we'll go to sphere 1, to the object tab, and let's just put that radius down to maybe 45. So we've got a much smaller sphere. And by the time we get to frame 150, which is when the animation of our first sphere stops, let's get this positioned in where we want it. So we'll move it in, something like that. And move it down, something like that maybe. Okay, that looks good. So let's go to our sphere 1, coordinates, add those keyframes, and then we can go back to the first frame, and actually we can maybe offset this animation a bit. So maybe at this point we can, remember, we want to pull it back in the Z. Oh, in fact, that's just looking nice using the Z animation, isn't it? Let's pull that back to, say, here. Add those keyframes. And then let's hit play, see what we get. Yeah, so that's looking really cool. Nice one. So let's do another sphere. Let's grab this one, hold Control, drag it down. Now we've got 2. This one, let's go to our position keyframes, animation, delete all those, and then we'll bring this one down here. Now, just so we have a different noise pattern with this one, let's go to the sphere 2. This is our last one that we've made, and we'll go to the displacer, and in the shading, in the noise, let's just change the seed, and that's just going to ensure that we've got different deformation. That one looks fine. Okay, we'll go to our frame 150. So this is where we want it to end up. All right, so maybe something like that. Go to sphere 2, coordinates, keyframe those. And then let's go back to this frame, maybe this one. And we'll pull that out on the Z and add keyframes. Okay, and let's have a look at what we've got now with our 3 spheres animating. Okay, that's looking pretty cool. All right. So one thing that we can adjust with these keyframes is you'll may notice that we don't have kind of a linear interpolation of this. We've got an ease in and an ease out of this animation, and that's just the default keyframe option in Cinema 4D. So look, if we want to look at our keyframes and how they are interpolated, we can just go down to this button here, which opens our dope sheet for our timeline. Let's make a bit of room. And here, look, we've got sphere, the first one, sphere 1 and sphere 2, and then all of those keyframes. So if we hit H, if we actually, look, let's select all of these. If we hit H, it will frame all of those keyframes. So now all the keyframes are selected. And look, you can see by default, these keyframes are set to spline, which means we get an ease in and an ease out of the animation. And we can visualize that if we change from the dope sheet view here to the F-curve mode view. Let's click on this. The same keyframes, but now we're looking at the F-curve, and you can see, look, we've got these Bezier handles. So let's change it from curve to linear. Click on linear. Now these have turned into linear keyframes, and we won't have an ease in and an ease out of our animation. So then we can click off this dope sheet button, and now we've got slightly different animation because these spheres are animating in a linear fashion from their first to their last keyframe. So that's looking really cool. I think arguably we don't really want this starting to erode our lollipop here. It'd be better if this was starting nearer the edge of our lollipop. So let's sort that one out. We'll just deactivate the Boole so we can see the spheres, and we can identify why that is happening, because when it comes in, that's the first bit it's touching. So what we could do in our sphere 1 is move our X axis to something a bit more like that, add a new keyframe, and now as we go through the timeline, it's going to be more the edge that's hitting it. So let's activate the Boole again. Let's bring that camera back round, hit play. Okay, that's looking good. And excellent. So we have our Boolean type set to A subtract B. We're joining these spheres to get that animation working, and we've animated those spheres, which mean that we're getting our mesh kind of animating, looking like this snow is cracking, melting away. And this is going to be the base mesh animation in which we can then add our particles to get the full effect. So let's move on to those particles now. So if we bring our picture viewer back in, have a quick look, we can see now that we have made our animated geometry. You can kind of see that happening and a better understanding of what's happening underneath these particles here. We've got our animated geometry moving back, and as it moves back, the particles are then released and kind of blown off in this really nice organic way, revealing the candy below. So we're not going to be worrying about these residual particles yet. That's something that we'll do much later on in the process. We're just going to look at these animated particles, and we'll start just by using one emitter. In the end, we'll have a different emitter for every type of particle. So we'll have a large clump emitter, we'll have emitter spitting out these little kind of more dusty snow particles, and then we'll have another separate emitter for the lights, but they'll all use the same process. So this is what we need to get set up. So let's bring in a new X-particle system. Let's go to INSYDIUM, X-particles system, and this one, let's call this one system snow particles. All right, and we'll just put that system that we've used at the top. All right, so in this system, again, we've brought a default emitter in, and what we need to do is we want to emit particles from the volume of this shell. So all we need to do is go to our emitter and go to the Object tab, and again, change the emitter shape from the default rectangle to an object. And then we need to say, what object do we want to emit from? Well, we want to emit from this snow shell, the thing that's in our Boole as our A object. So let's bring that down. We don't want to emit from the polygon center. We want to emit from the volume. We want particles all inside this shell. So let's change that from polygon center to object volume. All right. And then in the emission tab, again, we only want to shoot these out on the first frame. So let's change it from rate to shot. The shot time we can leave at 1, and we want loads of particles. Let's put 100,000 particles, and we don't want any speed. So let's go down to the basic particle data and get rid of this default 150 speed. We'll just put that on 0. And now if we go forward a frame, and let's just make the Boole and all that stuff invisible, there are our particles which are born inside our shell. Okay, and if we make our Boole visible again, let's just switch some of these spheres off actually inside our join, so it's not having to calculate, make loads of calculations at this stage. We can just do this with one sphere. So now if we hit play, we've got our mesh going back, revealing all of these particles that were born within the volume of that snow shell. And this is what we want to do. We want these particles to be blown off in the direction that we choose once the kind of Boole has disintegrated away the shell. So how are we going to do that? Well, let's get the movement sorted first. So let's just minimize our Boole object so it's a bit tidier in our object manager. So we're going to bring a modifier in, a particle modifier, and we want to modify the motion of the particles. We want to move them. So let's go to the motion modifiers list, and in here we'll take an XP wind. Now, if I just move this out, the XP wind, look, you can see we've got this big fan and we've got this arrow pointing in the plus Z direction. So if we hit play, that wind is going to blow our particles and accelerate them out in the plus Z. So that's not what we want. We need them coming exactly the opposite way. So let's go to our XP wind, and we can hit R for the rotate tool, or just click on the rotate tool button here. And then on this heading, let's just turn it around so it's kind of pointing not quite perpendicular to the surface, but blowing it that way. And we'll just leave it like that for now. So now, if we just move that camera around, now if we hit play, all of those particles are immediately being blown by that wind. So what we want to do is we don't want that wind to be blowing them straight away. We only want them to be blown once they've been released from the shell geometry. So how do we do that? Well, let's just make that wind invisible in the viewport. What we can do is use the same sphere geometry which we're using to cut out of our Boole. We can use that to switch on the wind. So this is how we're going to do it. In our emitter, we're going to go to the questions tab and we're going to create a question. Now, if we add a question, you're going to see a couple of things happen. If we add a question now, you can see if we go to the object manager, under the questions null, which was empty, we now have this default particle age question. And if we go back to the emitter, in the questions, we have that particle age question in this window. So to look at and adjust the settings of that question, we go to the particle age settings here. So by default, the question type is particle data. That's just what's brought into the scene, and it's an age-related question it's going to be asking of the particles. That's not what we want. We want a position question. So in the question type, let's have a look. We want a question based on the particle's position. So let's click on that. And then these are all of the different positional questions that you're able to ask of particles. Loads of different ones: distance to camera, distance travelled. We want inside volume. So let's click on that. So all this is going to do, every frame, it's going to ask a question of every particle: are you inside the volume of something? And what is the something we want to know whether they're inside of? Well, it's the same thing we're using in our Boole, isn't it? Let's open up our Boole. We want to use this XP join spheres. If a particle is inside the volume of any of our spheres, then we want it to be blown by the wind. So let's put that join into the object. Okay, so we've got the question set up now, but what we need to do is say, what do you want me to do if the answer to that question is yes, I am inside the volume of these spheres? Well, we want to activate this wind modifier. So in the question, if we move further down, we can either set up an action, which we'll explore a bit later, or if we come further down, look, we can activate or deactivate modifiers. So we want to activate the wind modifier. So let's put that in here. Modifiers to activate. Let's drag in our wind. So now when we hit play, the particles should be static, but as soon as they are within the volume of our sphere that we're also using to cut out our geometry, we activate the wind. And there, look, we've got it. It's working. Brilliant. And it's a really cool effect that's virtually automated. Excellent. So now that we've got that, we could add another modifier here. So at the moment, we're just blowing these particles. But let's say we want to give them a bit of turbulent movement as well. Well, we can go to our modifiers, to our motion modifiers, and let's pick a XP turbulence. Now, if we just press play now, the turbulence is going to affect all of those particles straight away, and it's shattering the illusion. So what we need to do is do the same thing with the turbulence. It needs to be added to that question. So it's only activated when the question's answered. So let's go to our inside volume question, back down to that bit where we're activating modifiers, drag in our turbulence, and now we're getting the same thing with our turbulence. It's only activated once they're within the volume. Excellent. Now we could maybe go to our turbulence and reduce the scale a bit. Let's put it down to 40. We could increase the strength up to, say, 8. And let's have a play from that. And now we're getting it blown away and we're getting a bit of turbulence. Possibly too strong. Let's put it back down to 5. But there is a very cool effect. And this is the basic strategy for how we are going to get this to look like our beauty. Let's go to our join, which is our B object in the Boole, and switch back on those other spheres. And because we used the join as our volume in that question, now these bits, when they get cut out by our spheres, are going to have the particles move as well. All right, and there you can see that that is our basic technique. And if we bring our picture viewer back in, it's exactly what is happening here with our particles. They're being released and blown by the wind and the turbulence and the other modifiers once they have entered that sphere, which is being used to cut out our snow shell, and you can see them blowing away. And the result is this brilliant look, which really is greater than the sum of its parts. So that is where we'll leave this first setup tutorial. We know how to make the lollipop. We've made our snow shell, which is this casing. We've learned how to animate that geometry to kind of crumble and melt it away. And then we're using that same rig to drive the motion of our particles that are generated from within that snow shell. So now we need to make this much more sophisticated, and that's what we'll be exploring in the next tutorial. We'll be introducing particle groups, multiple emitters, and much more modifiers using techniques like data mapping to get some more control over the movement of these particles.